In this video I'm going to show you how I created the screw in SketchUp that you see in my profile picture here, and also show you how I printed that out on my 3D printer. First of all, let's just zoom in here. Okay, we're getting closer. We're getting closer. So there's the 3D printed version of the screw. This is straight from a SketchUp model. I like how easy it is in SketchUp to make basic shapes. And of course I found out that you can export STL files from SketchUp too. For me it was a very easy, accessible way to start 3D printing because I was used to using SketchUp from before I got my 3D printer. I just wanted to see how far I could push SketchUp, like how complex, how complicated a shape I could actually make on SketchUp. To me, screws have always been fascinating, and it kind of takes you beyond that normal sort of plane and line and extrusion sort of work that you normally end up doing on SketchUp. This has ended up being quite a long video because I wanted to do a practical test of actually screwing the screw into something. I wanted to show the print process. I wanted to give a few pointers about how I actually built the screw in SketchUp to start with. And also it seems natural to talk a bit about my 3D printer, which dates from 2013 but probably in design goes back to about 2009. So please do bear with me. Here's the screw being printed. In a few moments you'll see how it dealt with actually being screwed into a wall. So I noticed that this outer kind of shroud structure actually became loose during the print. I probably could have done without that. This kind of structure around the screw kind of evolved over several attempts to print this. By printing this cylinder around the screw, I was able to clean the screw print itself up a lot, because if the retraction didn't pull all of the plastic back into the extruder, then it would kind of be left on this outer cylinder instead of being deposited on the screw thread. But as you see, if I lift this off, this support that was automatically generated when I decided to print the screw tip down probably makes this unnecessary, because there's less need to actually clean the tip of the extruder, because the screw is kind of lightly touching the outer support all the way around. The reason I decided to print the screw facing the tip down was because it makes a cleaner print for the top of the screw, which as you can see is a flathead. That is to say, it will take a flathead screwdriver, and if I'm careful I should actually be able to remove the screw from the support using the screwdriver. Well, that seemed to go pretty well. This is a kind of scary moment because the screw itself is quite fragile. If I wind it in the direction I would have wound it if I was removing it from something I'd screwed it into. see it actually turned out pretty well. The tip isn't quite as pointed as I might have hoped, but it will still function as a screw. The thread itself I'm very happy with. The only real untidy area is here on the base of the head, and that's probably from when this outer casing started moving around. But this should be easy enough to just remove like that. It's a while ago since I made this, since I modelled this, but I believe that this is a screw similar to the one that I modelled it on. There's quite a few differences because I made decisions on what was easier to print, but it's fairly similar. Just need to put a little bit more pressure on it. I'm really worried about snapping it, of course. Go. It's found its thread. I can feel that the whole thing is bending a little. It's a little bit elastic as I screw it in. But in all, that is a screw. It'll go in, it'll go out. You can see the diameter of the drill bit that I used to drill the pilot hole. It's pretty much the diameter of the lowest part of the thread there. It's going to be hard to talk you through the whole process of drafting this screw in SketchUp, but I thought it would be quite interesting to at least try. You see, this head is not the one that I actually printed. I printed a flat head screw instead, because this just didn't come out well in the print. I really wanted to create an authentic screw head in SketchUp, so I pretty much managed that, but it just didn't work well on the 3D print. As you can see, for the shaft of the screw, for the thread of the screw itself, I actually had to split this into polygons. There probably would be an option to make this out with smooth surfaces instead. Like, the problem with SketchUp is I noticed that when you try to create smooth surfaces, they end up becoming discontinuous pretty quickly. That is to say that SketchUp doesn't know quite how to join the surfaces together. So splitting this up into polygons meant that I could manually repair and join surfaces together a lot more easily. It did obviously take quite some time, but at least I knew that the results would be possible to 3D print, because of course if there are ambiguous faces, discontinuous faces, etc., it's basically impossible to export the model from SketchUp to STL. The tool that I used to create the STL file is a plugin that I found, which is very ubiquitous. It's all over the place. Just export to DXF or STL. You would just say support export entire model, millimeters probably if you're 3D printing, and then polyphase mesh, and that would create an STL file that you can then import into Slicer, for example, to create your G-code finally. The thread itself, there are some really good tutorials about creating threads within SketchUp. I'll just see if I can do a bit of that now. Essentially what you do to create a spiral, make a circle with a reasonable number of sides. Again, if you want to 3D print, don't make loads of sides, just make a sensible number that you can actually manually work with. So choose the radius that you want in millimeters. So if it was a screw, it would likely be 3 millimeters. So I'll put 1.5 in there, then just zoom to the extents of the model. Then what you want to do, explode curve, delete that middle bit, delete all but one of these, and then I think the next step is to move one of the points upwards along the blue axis. So I'll just choose 0.3 of a millimeter, and what I'm going to do is select that again and get that little plus on that rotate thing. Then if you know, for example, I had a 24-sided shape, so 360 divided by 24 is 15. So if I rotate this by 15 degrees and then do times 23, then you get 24 of those sides all angled upwards. Next I'm going to select all of those and then move that point there. I'll do another little plus thing. On a Mac you press Alt to get that plus. Move that up, and then I'll do times 23. Then you get a spiral there. I'm going to delete all but one of those spirals. Then if I select all, I can scale that around that point, and that will set the final pitch or the final angle of the thread. So all I've done now is create a second spiral with a diameter slightly less than the first one, and I'm just going to set that to the same pitch as the first spiral using scale. I already scaled it a little bit, but I need to get it exactly the same, and then I'm going to rotate that around the origin so it kind of lifts up relative to that first spiral. I'm going to make a copy of this spiral by rotating again using that handy plus rotate tool. This is all very rough, but you could of course experiment a bit and make this more precise. But then what you can see, you started to get, it kind of suggests a V shape sticking out. And what you can do then is start to join up the points to fill in that V. So I exploded those components now, and that means that I can start to join together the endpoints of these different parts of the sections of the curves, and I start to build up a screw thread style pattern just on the bottom here as well. I'm being quite rough here because the original screw took me quite a long time to draw, so that's why I'm not putting in any precise measurements. But you can see how this would, if I continued, result in a full screw thread pattern. And then if I join these up, then you'll get the kind of flattened area between the threads. So I'll just continue, I'll do that a little bit and continue with this. So that would be kind of your, so that area there would be kind of your flat kind of valley of the threads, and this is like the peak of the threads. There are probably better words for this. So once I created that, all I did next was select the whole thing. Imagine this is all filled in, and then I would just need to go do another copy move. I think I created components at this stage, but you just do copy move and continue, and then you create your entire screw thread. I think that's enough for now. I don't want to give away all the trade secrets, but there you go. I think that's enough to let a curious person have a go. So this is my 3D printer. It's a Mendel. It's actually quite dated now. It's quite old-fashioned. I think the new Prusa designs look amazing, and they've made big improvements on this one. I actually built this in 2013 using these printed parts that I bought off eBay. I kind of wanted to learn how all the electronics, etc. works from the ground up, so I tried kind of buying different bits from different suppliers and just seeing how it all fitted together. I mean, this is obviously a self-build thing, so it wasn't a straightforward process. I really wish I'd actually filmed this, but I didn't have a YouTube channel back then. I think it probably cost me under £500 to make this machine. I was just looking at the RepRap family tree on the main RepRap website just now, and I saw that the Mendel was actually not very different to this version of the Mendel. Was created in 2009, so this really is an old man when it comes to 3D printers these days. In fact, I wish I'd filmed it, but myself and my friend Savas, who now has a YouTube channel, we actually tried to make this out of wood because we were desperate to have one. Back in 2009, 2010 I think it was. That didn't really work out. Because this is a self-build machine, I kind of found my own solutions to various problems. There's quite a lot of customized bits on, some that I designed myself, and some that I printed out from Thingiverse, so it really was improving itself right from the very start. For example, this assembly holding the filament reel on top of the printer, I kind of, first of all, I printed these general purpose parts off on the printer. I didn't know exactly how I was going to build this filament stand, but these parts can accept threaded rod in various different angles, and I kind of kludged together this filament stand in the best way that I could. These parts were actually printed out. I was frustrated with the print speeds to start with, so I bought a very, very large nozzle, something like 1mm, and printed out with 0.5mm layer height, and I got these very chunky and strong parts out of it. Obviously they're quite ugly, so I'd never use it as a finished part, but as a utility part, they're great. On the base are these feet that I printed out from a design on Thingiverse. You just print them in two sections and then they snap together. That was really important to minimize the noise from the printer, because if you put one of these things directly on a solid worktop like this, it resonates really loudly when the motors move. So just to keep friendly with the neighbours and to stop driving myself crazy, I printed out these feet, which cuts the noise down immensely. This one's actually broken, but it lasted for now something like 4 years, so that's pretty good. This assembly here is a kind of primitive manual Z height setting system. This is the Z home switch here. When I first bought this printer, there was a very primitive method to set the Z height, which was literally to clamp this switch on like a slightly different clamp, but essentially you would just clamp it onto the rounded bar at whatever height you wanted the Z home to be, and just essentially hope it was right, because it was so difficult to adjust. But here there's actually there's a bolt running through the top piece which touches onto that switch there as when it lowers down, and by turning the bolt you can get a far more precise Z height. However, of course, compared to the modern Prusa printers, which have the magnetic magnetic sensors to find, or proximity sensors to find the bed height, and obviously all these sophisticated tools to work out in software the curve of the bed. This is pretty obsolete as well. This is the first part that I printed myself using the printer. It's a filament guide for this particular sort of geared extruder, which is probably also quite ancient now, because there was nothing to guide the filaments into the correct place on the bolts, and obviously into the heated area either. So this was a painstakingly printed out part, which was then what was necessary to actually continue printing far more reliably. On the base of the motor assembly on the extruder, there's this other printed part which is an adapter to fit J-heads. I don't even know what sort of extruder I was using to start with, but it was very clunky. It had a resistor to heat up the extruder. As soon as I started using the J-head style, I had far more success printing. Well, I hope you found that interesting. At the moment I can't see a practical use for a 3D printed screw. I just think it's interesting to try to push the boundaries of what's possible with 3D printing, especially very old 3D printers. And probably this could be developed into something which does have a practical use. I guess that's what science is usually like. Not that I'm exactly a scientist. Please do like, subscribe for more open source electronics, kind of makery sort of stuff. I make videos about Arduinos, including the obligatory Arduino watering system. I modified a Chinese laser cutter to run on G-code, and I started using that to make laser cut marquetry. I also made a blog about building my own CNC machine from scratch, using acrylic sheets and the open build C-beam system. So there's a whole playlist which will kind of show you the process, and all of the designs for that CNC machine are available for you to download, and you can make your own. I used that CNC machine to engrave some veneer to create a replica of the puzzle box from the Hellraiser series of films, which was my entry for the Instructables Halloween contest this year. There's a lot of miscellaneous stuff on my channel, but if you're into maker stuff, you're probably going to find it interesting to subscribe. I'm really happy to have got past the 700 subscriber mark now. I think it's great that even more people are seeing my videos. I'm excited to see what the rest of 2017 is going to be like.